If you've ever had to put together some sort of a web API that people can access over REST or SOAP or something like that, you're likely to have used web API for that.
Let's mash on that.
Hi everybody and welcome to another episode of the Asp.Net Monsters. In today's episode we have a special guest star with us. It is Darrel Miller, who is now a developer with Microsoft on the Azure API management team, which he tells me is pronounced Amt.
It sounded very German.
A lot of skilled Germans at Microsoft.
So-
in charge of team names.
Darrel, what kinds of things are you working on these days?
Well, funnily, you should ask that because really most of my work right at this moment in time is working all on SOAP stuff.
Oh, that was totally a joke. I thought SOAP was dead.
Oh, well, no, actually, there's lots of enterprises who still have lots of SOAP stuff left around that actually still works. But obviously, there are people who would like to communicate with those and maybe don't want to talk SOAP to them. So what API management as a product kind of can sit between a client and a server. So our first phase is we're working on just doing what we call SOAP pass-through. So you can use our API management to do throttling and other manipulation of the message. And then the next phase will be to do kind of a pseudo REST to SOAP type of translation so that we can make a pretty HTTP front end on a SOAPy back end.
Okay, so to take it back for people who are drastically young and upsettingly so, SOAP is a simple object access protocol. Is that what it is?
Well, it was in 1.1, and then they realized what a terrible acronym that was. So as of version 1.2, which is going back to, I think, round about 2002, 2003, they decided, no, it's just SOAP. So no more acronym.
So this was a way of sending messages back and forth between servers, like better than Corba, but not necessarily all that modern. Wasn't there a thing where you could like send SOAP over email? Wasn't that like a big thing back in the day?
Well, SOAP in itself as a protocol is what we call transport agnostic. In theory, it can be sent over lots of different protocols. So it's a whole messaging layer over the top of other protocols. Most commonly, it's over the top of HTTP. But yeah, it could quite easily be run over SMTP.
Fax
or,
machine.
in theory, FTP.
Okay, cool. So the stuff that you're working on is it's like tools for managing my web API if I've got it hosted inside of Azure. Is that right?
It's if you host your API anywhere. We basically just take advantage of the layered notion of the layered architecture of HTTP, and we're kind of like a proxy, a little bit like Nginx or Squid or HA proxy. We sit in between the client and the server, and we can do all kinds of manipulations on the messages from, as I said, request throttling, managing subscription keys. I think the most obvious example that I can come up with as to where our product is really useful for somebody is you come up with this brilliant idea one day and you say, I'm going to write this API that does X, and I'm going to make me a lot of money like selling this API that does X. And you go off and you code your API and it works and it's wonderful. But now you need to turn it into a product, right? You need a website where people can come and sign up and say, well, I want the free edition, or I want the Uber super edition that I'm going to pay $5,000 a month for. And like all of that infrastructure, you don't want to have to build yourself. And so all of that kind of stuff we can just bring along in a package. You sit your API behind us and we expose that API to the outside world and do all that value add that is necessary for bringing a product to market, but not essential, but not part of your core business.
So the API management piece, that part is hosted on Azure.
Yes.
But the API itself that you're managing, that might be on premise.
Yeah, can be anywhere. And you can take advantage of all the kind of Azure stuff for doing VPNs and VNets and express routes to go back to on-prem type environments if you want.
Okay, fabulous. So once I've come up with my super idea, I put you guys stuff in front of it, and it'll handle like subscriptions and things like that.
Yep.
Like I can say this group of people have unlimited access, and this group of people who haven't paid me any money only get 500 requests a month. That sort of thing.
Yeah, wow. and we've got caching infrastructure built in there so that you can just basically flip the switch and turn on HTTP caching. And if you get really big, we can geo-distribute those caching so that they can be cached closer to where the customers are. And that kind of turning it into a product is the one side of the business. The other side of the business that maybe bigger companies are more interested in, where they have these kind of legacy APIs that have kind of evolved over time, and they want to put a more consistent, fresher face on it so that you can do certain manipulations in the management layer. So you can take a bunch of APIs on the back end, consolidate them, and present them as if they were a single API. You can take 5 different backends that use 4 different security mechanisms and put them all behind API management and just have one OAuth2 type JOT token type of authentication on the front end. So there's that kind of facading is another way that the product is used in order to create consistency. And also as a discovery thing, large organizations, you get companies who are building APIs throughout the organization. I need an API to do this. Well, where is it? Well, we provide a portal where developers can go to that portal and say, oh, these are all the APIs that are available in our organization. How about instead of rewriting and reinventing this, I'll go and use this existing one that's already there. And we give all the statistics, see how often an API has been used. So you can go and look, nobody's called this API in the last 2 years. Maybe we can deprecate it and turn it off, right?
Oh, okay. Yeah, that's a really interesting idea. So what sort of mechanism do you guys have around if I want to go and call a service? Is there some sort of schema or something that I can look at? Is there a WSDL?
Well, we have import mechanisms, so you can import Waddle, you can import Swagger, or should we say OpenAPI, and I've been working recently on the WSDL import. So soon you'll be able to import WSDL into the, and then that basically exposes a set of operations, and then you can apply policies on those individual operations in your API.
Okay, so Swagger is a schema for people that they can go and use it. Is it designed to be like programmatically readable, or is it more
Swagger
human?
Anymore, right?
So it's changed. Like I totally missed that.
Okay. So
OpenAPI.
Let me try and tell you the story there. So Swagger was created by a guy named Tony Tam who worked for Reverb, and it was all open source. And then a company came along, Smart Bear, and they hired Tony and bought the the IP, I guess, for and the trademark for Swagger. But in order to keep the popularity going and have other companies get involved, people didn't want that the IP for the actual spec to be owned by a particular corporation. So Smart Bear agreed to, or they decided to make the spec be managed by a foundation, actually the Linux Foundation. So there's now a group called the Open API Initiative who are responsible for the future versions of OpenAPI, which used to be Swagger, but the name Swagger still exists, but it's now used as a name for the tooling, Swagger UI, Swagger Editor. So those are open source tools that allow you to get the UI and do the code gen and all that stuff. That's now managed and run by Smart Bear, and the name Swagger will be a brand for all of that set of tooling. But the actual specification itself is now technically officially called OpenAPI. But getting people to actually use that term instead of Swagger is extremely difficult. So.
Yes, as I've handily demonstrated herein. I'm surprised that the people would take a company called Smart Bear seriously. I feel like that's a comedy name for a
Change
company.
starts here.
Well, the irony is SmartBear, basically, their main product is Soap UI, right? The soap testing tool.
I was really hoping their main product was like a bear trap or something. or so, like if they
That
have
would be
not
a
branded
dumb
one of their
bear.
products Yogi Bear, they've missed out on a terrible opportunity there because he was smarter than the average bear. Okay, so this open API thing.
Yes.
So I go and I find a registry of services in this open API format.
Well, there is no Well, there isn't any registry that's really taken off yet. There are a couple of efforts. I think it's at the website called apis.json or jasonapis.org. I'm not sure. There is a search engine that will help you search for them, but there's no real equivalent to UDDI yet, which UDDI was the directory for all the SOAP services. It's one piece, so OpenAPI is a specification that allows you to describe the set of resources that you've made available on your API, and it can be used for a variety of different purposes. It can be used to help generate a skeleton of documentation. It can be used to generate client code that will interact directly with an API, because the OpenAPI document will actually describe all of the media types that will be used, what the status codes that are commonly expected to be returned, and the shape of the payloads that are returned. We'll go into all those details. So that can be used in order to generate client code. In fact, Microsoft are actually a big adopter of it. If you look at a large number of the Azure SDKs are generated based on Swagger descriptions. The Azure properties like API apps and logic apps all use Swagger as a way of describing the interfaces to be able to integrate all of those components. So Microsoft have taken a fairly big bet on using it as an integration tool. But there's lots of other companies, Apogee, lots of other companies, IBM are using it extensively, and so there's lots of companies who are using it as a description of choice. Not that it's the only one. There is also RAML, and there's API Blueprint that are two other competing API description formats. So, as with all standards, it's always good to have a large number of choices, right, to choose from.
All right. So if I have a web API application that I have built, and now I'm ready to expose it to the world. So I want to add some I was going to say Swagger to it, but some open API to it, which would have been a much better sentence. Anyway, if I wanted to add some open API to it, what's the easiest route for me to do that?
Well, I would suggest stepping back a little bit, because you should really make a decision earlier on. There's kind of two styles of doing API design when it comes to using these kind of description formats. There is contract first and implementation first. And you can actually do it the other way around, where you start by designing the description and use that as your source of truth. And then some of the tooling, for example, I know the API Blueprint guys, API-ary. Try saying that. It's a tricky one. They have tools that will create mock servers based on that description. So that will get you started with a server and create scaffolding from it. There's also a tool called Swagger Inflector that actually uses the document, the specification document, as like a routing tool. You add some additional annotations to the document, and you say, for this particular operation, I want you to go and hit this controller. And so therefore that becomes the source of truth for your API and actually enables the routing. So you don't even, like in the .NET world, you wouldn't even need to create the routing table. You don't need to use attribute routing. You just basically could load up a an open API document and use that as your router. So that contract first style of building APIs is actually becoming a little bit more popular now that tooling is starting to become available for it. If you don't go that route and you build an API first, or you're coming in with an existing API, there's in the .NET space anyway, there's a tool from a guy named Richard Morris called Swashbuckle, where you simply add it in as a NuGet package, and it will create some additional resources available, and it is dependent on the API Explorer class that's built into Web API, and it will use that to basically reflect over your set of routes and create all the metadata, and it creates a Swagger document or an open API document for you.
Well, the version that we're using on our project still says Swagger when you generate it. So
yes, that's
Simon and I are actually using that actively on our project right now, and it is a great little add-on.
Yeah, the challenge is Swagger or Open API is an opinionated way of building APIs, and it is quite possible to build web APIs that cannot be described in Swagger or even in the newer version of Open API. So you can run into some difficulties when you try and reverse generate that document, the specification document from your API, because sometimes you just did things that aren't supported in the description format.
Yep, done that.
Yeah,
I think the one that got me was two methods that had the same name but different signatures.
Yes,
which is legal except not there.
Well, in OpenAPI, it's by path and method. That's the distinction.
Right.
Query string parameters cannot be used to distinguish. Now, the interesting thing is there is version 3 of Swagger OpenAPI is currently in the works. And one of the open issues still left to discuss is how much of real URI templates, the IETF defined URI templates that actually define where query parameters can fit in a URI, whether those will actually come in and be allowed to be part of the path, which will end up making the naming a little funky. But there's actually a lot of new stuff and interesting stuff that's gone into the version 3 of the spec so far. There's a small working group of people, and a lot of the people who come along to the GitHub repo and have done pull requests. We've had companies like Bitbucket come in and do submissions. And recently we added a mechanism to allow the description of static links between resources within the description. So you can now describe an operation and say, well, when you've got this response back, from here, you can go and get another resource by using these parameters from the resource and feeding those into this other operation or into this other URL. So it's not a hypermedia solution in that the links don't actually come back in the response, but it's a way of describing how a lot of your resources in your API are linked together, and that can then be used to help build links in your documentation so people can see, oh yeah, from here I can go to here. And also in client generation tools, you would be able to create methods on response objects that would be able to easily jump from one response over to another response. It basically just saves somebody from having to write client-side code that reaches into a body, grabs the right ID out of the body, and then goes and puts that correct ID somewhere in the request for to grab some other piece of information. So there's all kinds of interesting things that are going into that the new version of the spec.
That sounds interesting. If I'm designing an API for this stuff, a point that I'm always curious about is whether it's a recommended practice that everything should just be kind of like a primitive. All the parameters that come into my method should be primitives. So I just have like 3 integers that are coming in, or is it a better idea to define a custom model and use model binding to pull those parameters out of there?
I'm a bit of a stickler when it comes to this particular topic, and
Yes, we kind of suspected as much. It may be the leading question.
One of the things that I find really valuable is keeping a distinction between parameters that come in on the URI and parameters that come in, and information that comes in the body. Because HTTP has a very different way of describing, it has a very specific way of describing the content that comes in the request body. It's got a media type, and that media type defines the semantics of that particular body. When it comes to the parameters, the parameters that you put in the query string and the parameters that you put in the path, well, HTTP and the URI template spec really doesn't have a whole lot to say about them. They're just kind of strings that can be interpreted however you want. And you're always going to make your life easier if you can keep those structures in the URI fairly simple. I've seen some fairly effective applications of more sophisticated model binding on certain parameters in the URI. Just stuff like latitude and longitude, X and Y coordinates, those kind of things where there's multiple parameters that actually really naturally fit together, RGB values, right? Those kind of things, yeah, okay, fine. If you want to map those into a more sophisticated type, then using your framework infrastructure to do that simplistic, an amount and a currency, those things, they fit very nicely together. When it comes to, I sort of see the request body as quite a different thing, and there's two aspects to dealing with bodies, and it doesn't matter. See, whether you're looking at a request body coming in or a response body going out, I look at them as identical, right? They're a blob of bytes that are described by a content type header. And technically, according to web architecture, that media type is supposed to tell you everything that you need to know about that particular payload. Now, we all know that we build APIs every single day that use the content type application/JSON, which really tells you absolutely nothing about the content in there. So as a receiver of information, whether you're a server receiving an inbound payload on a post or a client receiving a returned response, you need more information in order to be able to process that successfully. Now, where do you get that information? You either know it beforehand, well, on the return path. You either know it because, well, I called this URL. So therefore, I know because I called this URL, I know I'm going to get application/JSON back. And I know that because I looked at an open API document, that there was a schema, and this is exactly the shape of the body that I'm going to get back. And that's a valid approach. It's just a fairly tightly coupled approach, because if the server changes anything, you could break the client. On the other approach is you could start to get a little bit more sophisticated in the way you describe things. You can add a secondary information, and some people refer to this distinction as the format of the payload versus the application semantics. And there's a few ways of attaching application semantics. If we go back to the days of XML, you could have namespaces on there. If you look in JSON now, it's quite a common convention. You'll see at the beginning of a JSON file a $schema property. And that has become a convention where you point to a JSON schema, and that will describe the shape of the particular JSON payload. There's some advantages to not actually putting that application semantic identifier in the payload and actually putting it in the headers. The whole layered thing about HTTP is the idea is that as a message gets passed around your system, it goes through various intermediaries, and it's really convenient if the intermediaries can just look at the headers and get all kinds of useful information from the headers without having to consume the entire body. So if I can look at a content type header and say, oh yeah, it's application/JSON, but they tacked on this extra little parameter called profile, and profile has an identifier for the application semantics telling me that, oh, it's an invoice, or it's a receipt, or it's a ticket for a bug tracking system. And
it also feels more appropriate to have that information in the header anyways, because that's not our body, right? If we're looking at the body as the message itself, the schema or the profile or whatever, that's actually not part of my message.
Yes and no. There are arguments both ways. I mean, if you go back to XML as an example, there's this idea of namespaces that identify the meaning of certain things. And lots of cases in XML documents, you'll see content embedded inside content. So you'll have one set of semantic meaning being as a payload of another load of semantic meaning. So having multiple namespaces in there can actually be useful. The challenge, of course, is, like the canonical reason for putting it in the headers is like you're using a mobile app and you either retrieve some data or you're sending some data, and the headers go first, right? And the server or the client can look at the content type and this application semantic identifier and go, I have no idea what this is you're sending me. Please don't send me these bytes because I don't want to pay for these bytes that you're sending me. So there's one advantage, but of putting that kind of identifier in the header. But I've heard valid arguments on both sides of it. I think the important thing is you got to realize that there's the format of the data, there's the actual meaning from an application perspective. It's best if that meaning identifier is actually in the message itself, because then if for any reason later on you need to change something and deliver a V2 of that meaning, that the client or the server can go, oh, yeah, I understand V2s. I'll process that V2. Or, oh, no, I don't understand that V2. I'm sorry, I can't process that. And they can adapt to change much easier rather than a system that's built around the assumption, well, I know exactly what I'm going to get, and it's never going to change. And if it does, well, I'm just going to throw up my arms and I'm going to crash.
So you actually touched on something, though, Darrel, that's actually a really important part. And everyone talks about this. I think Troy Hunt actually not too long ago, or maybe it was a couple of years ago now, said, how are you going to do this wrong? Was essentially the theme of his post, and it was talking about versioning. And there's so many wrong ways to do versioning. We didn't have you on the show because you're unopinionated. So we are curious as to, like you're talking about, like, the subject of the body of the subject of the message, the profile of the message, and there are going to be arguments pro and against having that as part of the message or part of the header. One of the things that comes into play when we're talking about versioning is the use of things like reverse proxy servers and things like that in order to do routing to appropriate stood up versions of the API based on version. That can either be parsed out of the URL, or it can be done in a header. There's other ways as well. Putting the version into your message, as you kind of inferred from schema changes and whatnot. What have you seen? What are like the big pitfalls? What are the things that would just, no, don't do that, and how do we navigate versioning?
Sure. Yeah. I mean, it's one of the most common questions that gets floated around, and I've kind of developed a perspective on versioning, and the idea is we're building distributed systems. We're not building a system that is controlled all by one organization where we can deploy everything all in a single unit, right? So we have to approach versioning differently than we do with compiled components that are linked at design time, compile time, and deployed together. So the happy path is to not version, to never version. If we can avoid it as much as possible, that's ideal. Unfortunately, we don't live in an ideal world, and sometimes we make changes or we need to make changes in order to deliver the business value that we're trying to deliver. We need to make changes that are going to break things, and therefore we need to introduce some kind of versioning. Now, once you've accepted, okay, we need some kind of versioning, now it's a case of, well, what is the appropriate type of versioning for the particular problem that we have? versioning of a document format is something that's worked pretty well in the past. If we look at the past of the web, you look at HTML as a format, you can take a web browser and you can pull up an HTML page that was created 20 years ago. Let me just make sure that,
Yeah, you can.
chances are it will still render, right? And we had certain pieces of metadata that we'd put at the top of the document in order to say this is this version of HTML. Now they've moved to an even more living model of HTML now, but that is one fairly effective way of versioning the content of a particular document. And it's by doing that, you can build both clients and servers that can simultaneously process different versions. So you can introduce new versions, and there are techniques taking advantage of like HTTP content negotiation, where a client can say, well, I understand this version of a particular media type, so could you send me only that particular version? Like GitHub, they put a v3 on the end of their media type for their API at the moment. So for the moment, everybody's talking v3. When they come along and introduce a v4, all the clients that say, I only understand v3, they'll continue sending the v3 version to them. And as new clients are built to understand the v4, the server can then say, oh, yeah, well, here you go. We have a v4 of it. So it allows this kind of progressive, evolutionary adoption, as opposed to the big bang of in 3 weeks' time, we're going to switch everything over to the next version. Or if you want to use any of these new features, you basically have to throw away your old client and build a new client against our new API that we've built. So those kind of big resets are the things that I think are red flags. And a lot of another technique that's used for versioning is putting a version number in the URL. And the important part of putting a version number in the URL is where you put it. If you have some kind of resource, customer resource, and you need to make a breaking change on it, you can create a URL that is /API/marketing/customer v2. You can just version that particular thing that is breaking and not change the entire API. But people don't tend to do that. They tend to look at it as, well, no, we're going to create a whole new version of the API. And they go, well, this is going to be breaking. So what we'll do is we'll wait and we'll gather together all of our breaking changes and we'll create a v3 that has all of our breaking changes in it. And they put the v3 at the beginning of the URL, basically invalidating the entire API. The problem is, chances are, only a small set of resources within that entire API are actually broken. So now it falls on the consumer, the client developer, to now go, okay, well, which ones are broken and which ones aren't? And can I build a client that works with both? Or do I have to start a whole new, do I need to create two different versions? You're making a lot more work. Basically, you're taking your problem where you have, as an API developer, a breaking change, and you're just saying, well, we'll let the client developers figure it out. It's their problem, right? But as somebody who's building an API as part of their business, you kind of want to keep your customers happy. So
especially if they're paying customers.
Yeah.
Preferably.
If you can minimize the effect of that versioning to just a small part of your API, then that's definitely, in my opinion, the best approach. So again, it's if you don't have to, and then when you do, try and minimize the effect of it, and try not to do these giant resets where it's like where you aggregate all of the changes together and then, well, sometime in 18 months this new feature will release, because then we can afford, the customers will be sufficiently happy with us after our last moving from V1 to V2 was painful, so we don't want to move to V3 anytime soon. So features get held back because it's potentially a breaking change. And there's really, once you introduce like a V2 of a customer, there's no reason why you can't keep the V1 hanging around for potentially indefinitely, right?
It doesn't make for as pretty of URLs, though.
Absolutely correct. Yes.
Of course, if it's an API consuming an API or a server consuming an API, I guess it doesn't really matter, right?
Well, that's the thing. When was the last time you used a mobile app that accessed some API and you saw a URL? You
Right.
just
Not
don't.
frequently enough.
You don't. Yeah, I mean, sometimes they would be handy, right? But
when you attach Fiddler in between.
Yeah, that's right.
Well, that as you said, the perspective, the way you put it, that was really helpful. I feel with versioning, there's just so much conflicting advice and guidance out there that I have a hard time even deciding what approach to take in my apps. So that was really helpful.
Yeah, and so many API guidelines I see, the first thing they tell you is, well, make sure you start out by putting a v1 in your URL because we're planning for failure. I mean, yeah, right. It is implied, and you really don't need it there. And as much as you can avoid it, because every time you put a v2, basically it means, yeah, our last design was a complete and utter failure. But okay, so here's one last little perspective on that breaking changes, right? Because we only need to version when we have a breaking change. But I have yet to hear anybody be able to describe what is a breaking change on an HTTP API.
Is that a challenge then, Darrel? Is that
I've only heard one answer to this particular question of how to determine a breaking change that I think is an acceptable answer to it.
I would say anything that adds a non-derivable new field to the request. So if all of a sudden you absolutely need to have an email address, that seems like it would be a breaking change.
But the business was functioning yesterday without that email address, right?
Right. So it's not necessarily an API change as it is driven by a business change. The business has decided that from this day forth, we shall always have email addresses.
Yeah. Yeah. But that is almost impossible to detect that on a technical level, that it's a breaking change. Because as you say, it's purely a business, maybe some new legal requirement has come in that thou shalt have this piece of information from now on. And even so, you could still accept that information without it by adding some kind of new state flag in there. It's like, we've captured this information, but it isn't ready to do this next step with it because we don't yet have that information. Mm-hmm. So you can work around those kind of issues by saying, well, yeah, but now we just have this new class of pieces of data that are not yet able to do these other interactions within the system. We cannot give out the student loan to this person because their file does not yet have this piece of information that is part of the legal requirements in order to give out student loans. So it can still be an accepted piece of information into the system. So the best answer that I've seen is somebody suggested literally they built a set of unit tests or integration tests, and they ran those integration tests against their API, and whatever those tests tested, if the change broke those tests, that is what they considered a breaking change. So when you're building a client application, you could go and look at those tests and say, okay, these are the assumptions that you're making. Because, for example, you could build a client against an API, and if you add a new field or remove a field, the client would break immediately, right? If you're using a very strict serializer, I mean, look at XML data contract serializer. If you change the order of the fields, right, you'll break the serializer.
Broken. So
how that client consumes the data is what defines what is and what isn't a breaking change. So by having a suite of tests and say, look, this is how we define breaking changes. And if you build client applications that do follow this same behavior, then you'll know when we make a breaking change that it might break your application or vice versa. This change didn't break our unit test, therefore it won't break your client application. But I mean, that's still a lot of work. and it's difficult to get all the information you need from that set of tests and reapply those over to your client application. But it's the best answer that I've seen so far.
I think it's a pretty good answer.
Yeah.
Yeah, very.
Okay, so we are, I think, drawing to the end of our time together here. So we want to thank you very much for coming on and presenting some fascinating ideas. It's certainly changed my thoughts, especially around versioning. I'm going to stop putting v2 right at the beginning of my URLs, starting like right now. But it's probably going to be a breaking change for people.
I'm going to start by putting v3 at the beginning, just that way people implicitly trust it a lot more.
You know what you should do? You know,
V10.
have you ever seen, like, you're driving around town and there's like Joe's Plumber, and they always have like unit 1005, so it gives you the impression there's like 1,005 units out there. You could just start all of your APIs with that. And people will be like, wow, this is a really mature API.
Mature. Yep.
Yeah.
Or some of us will go, wow, they made a lot of mistakes.
Well, if it works for Joe's Plumber.
Exactly.
Well, thanks, Darrel, or as you're known in some circles, Soapy McSoapface, I think.
Judging by his lighting there, I would also argue that he could be like the dark API knight or something. You know.
I like it. Well, thanks everyone for joining us again here on ASP.NET Monsters. Remember to like, comment, share, and send us an email with your comments and questions, just like these folks.
Right, so we've got Peter here who sent us a message asking in regards to, let me pull up the episode information, in regards to episode 57, loading related data from Entity Framework Core. Is this a good practice? We were calling the context directly from a controller, Dave. Isn't it better to keep separate the model between the repo and the UI side? So separation between what we're actually storing in the database versus what we're actually using in our views.
Yeah, there were kind of two questions there. So the idea of, should we be taking our entities, those models, and just passing it directly to our view? And in general, the answer there is probably not. We shouldn't be doing that for a number of reasons, which one of those is even on model binding on the way back. I think, James, you've pointed out some security problems sometimes with that that might not be super obvious. So always good to have some kind of view model, unless it's a really simple case where it might be easy enough to do that and just pass the model over. The other question that was around just using the context directly in the controller. And so this is your database context from Entity Framework. I think sometimes we're a little overly scared of doing that. We end up writing all these layers of abstraction to hide that away. There are lots of cases where if you're just doing a very simple query, I don't see a problem there with using your context directly in the controller.
We can be pragmatic about it.
Yeah.
And it's still, in EF Core as well, we do have the option for in-memory database. We can change the way that context operates in a development and a test environment, and it doesn't always have to go to an actual database. So there's other ways that you can test this without coupling yourself to SQL Server.
Yep.
Excellent. Okay, next question from John Marsing, who in regards to episode number, let's see here. Oh, it's flopping around on me. There we go. In regards to episode number 52, loading view components from a class library. And John's asking, what are some of the good use cases for view components? And he's suggesting that menu might be an opportunity for one.
Yeah, I think menu is a good option. Another one I use often is the concept of that login/register piece that goes that's often in the top right-hand corner of a site, and it's in the default template with ASP.NET projects. That's something that's there all the time, and it kind of needs to check is these are logged in or not, and there's that context information it needs to figure out, and that would be a good use case for a view component. And another one that I use in my examples often is that, the what's new section, where we're just showing getting some data from a news service and displaying what's new somewhere on our website, and we might reuse it in lots of different places in the application. So those are a couple of concrete examples.
Right, I've got a view, and I have to put something on here that's actually not really related to the stuff that I'm putting in here. That's one scenario where you can make that separation.
Yeah, and I think as Taylor mentioned in our episode that I forget the episode number.
Razor, yeah, we were talking about Razor with Taylor. Yeah.
So he said view components. One of the main use case I see for it is when you have some reusable piece of view where there's also some logic in what would have been a code behind in the past. So you have some kind of business logic that needs to happen. That's kind of the use case for view components.
Wonderful. Okay, well, thank you, Peter, and thank you, John. Please send us a direct message on Twitter with your addresses. We were going to be sending you out some fine ASP.NET Monster stickers. So we will get in touch with you, get your digits, and get those in the mail to you right away. Simon.
Great. Thanks, everybody, for joining us on another episode of the ASP.NET Monsters. And we'll see everybody next episode.
Cheers.
Thanks, guys.